Hey there, ladies and gentlemen. In this video, we're going to be discussing how to add and subtract radicals or expressions that have a square root symbol in them. Just as a quick little refresher, if we had an expression, something along the lines of 2 plus 3x minus 5 plus 5x, if I wanted to simplify that, I'd have to find terms that are combinable, aka like terms here. So if I have a 3x and a 5x, we could call that 8x, and then I've got a 2 and a negative 5, and we could call that a negative 3. So essentially we're going to be doing the same thing here, but instead of a variable like an x, we're going to be dealing with radicals, like a rad2 or a rad5. So I have an example here of 3 rad2 plus 4 rad5 minus 6 rad2. If I wanted to think of this like variables, I could almost pretend this was a 3x plus 4y minus 6x, in which case x would be like a rad2 here. So I'm seeing that I have like terms between a 3 rad2 and a 6 rad2. They both have a rad2 attached. So the 4 rad5 is going to remain unchanged. There were no terms for it to add or subtract with. Here, if I have 3 rad2s and I take away 6 rad2s, I would result with negative 3 rad2. So I'm subtracting the coefficients. 3 minus 6 is negative 3. The radical expression itself does not change. Now we might see future examples in which it's a little bit more difficult. Sometimes we might have to simplify radicals down. For instance, we have 2 rad 7 plus rad 28 minus 3 rad 2. Well, this rad 28, chances are, can reduce down. So we can go through and we can simplify this. Whether it's the prime factorization method or the perfect squares method, we can factor this thing down, and it's going to turn into a 2 rad 7 after simplification. So now I've got 2 rad 7 plus another 2 rad 7 minus 3 rad 2. Since these have the same radical component attached, the 2 rad 7 and the other 2 rad 7, I can add my coefficients together. So if I have 2 rad 7s here plus 2 more rad 7s, I would result with 4 rad 7, and then minus 3 rad 2. There were no like terms for that to combine with. Our last and final example here. By the way, if you need to pause the video to write this down, that would not be a terrible idea. We're going to do it in a very similar fashion, but first I have to make sure that all radicals are as simplified as they can be. 3 is a prime number here, next to the 4 rad 3, so that can't reduce down anymore. This rad 12, that can reduce down as a radical, and that'll simplify out to become 2 rad 3, and we'll bring down whatever coefficient was already up front along for the ride. Same thing here with rad 20. We can break down rad 20, again, whether it's the perfect squares method or if you have the prime factorization as your preferred method. This will turn into 2 rad 5. And we have a rad 24. There's no coefficient attached out front, so we'll break this thing down. And that's going to become a 2 rad 6. So here's what our expression has now become. We have 4 rad 3 plus 2 times 2, so that's going to become a 4 rad 3, minus 8 times 2, that'll become a 16 rad 5, plus 2 rad 6. So 4 rad 3 plus another 4 rad 3 minus 16 rad 5 plus 2 rad 6. If we can find like terms, we're going to simplify them and combine them together. Here I'm seeing 2 separate pieces with a rad 3 attached, so I can add those coefficients together. 4 plus 4 gives me 8, so 8 rad 3. There are no other rad 5s, so we leave this term untouched, minus 16 rad 5. And last, of course, we have the 2 rad 6. There were no other rad 6s in this expression, so we can't combine it with anything. This would be our final answer. When we do these, one big thing to note, the term underneath the radical, the value of the radical itself, will not change through addition and subtraction. Multiplying and dividing is a different story, but simply adding and subtracting will not change that value. As always, if you're stuck on anything, do not hesitate to send me an email, swing by for extra help, and we'll get through this together.